So moving on to this next one, again, we have to try, is it standard integral? No. Is it substitution? No. Can I rearrange it? No. I should try product. I should try integration by parts. There are pieces in here that I can choose. Now the way I choose it, I have to choose a U piece and a dV piece. And the way I choose it is, I need to select the dV part to be the most complicated part that I can integrate. So my choices would have been e to the x dx or x squared dx as my dV piece. Well, x squared dx I can integrate, no problem. E to the x 2x I can integrate as well, and this one is more complex than the x squared version of it. Okay, so I'm going to choose that one as my part. So when I write out my integral, my original integral pieces were e to the 2x, okay, dx, that's that part, and my x squared part, and I'm going to break it up into the new parts. So it's going to be uv on the outside of the integral, and then this is a key part. This is a part that is the make or break. Okay, this new integral that I end up with. Okay, so the parts I used were the u dv. I generate the other parts by differentiating. I integrate this to get the other part. There's my integral. So the new part that I'm going to integrate, or hopefully can integrate, is going to be e to the 2x over 2x dx. Okay, and I can simplify that out. And unfortunately, in this case, that new integral can't be done. Okay, so this cancels out, and I end up with x e to the 2x dx. So this can't be done. However, when I look at what I started with, this is a little bit better. And it's essentially the same form, which means then why can't I reapply integration by parts again? In fact, I can. Okay, and I'm only going to apply it to the integral. So this part's been resolved. Okay, but I can reapply integration by parts on this piece right here. And again, I can just break it into parts. I need a u part, okay, and I need a dv part, which is the most complicated part that I can integrate. Well, I already chose that as my dv part. Okay, so my dv is equal to e to the 2x dx. That means that my u part must be this part here, so u equals x. That's easy to differentiate to get my du. That dv part, I can integrate it to get v. V is equal to e to the 2x over 2. Again, I can now plug it into my formula. I've got my x, my uv, so my u times v as part of my formula, okay, just like I had it here. Okay, so but I'm going to put this in brackets, make sure that I have in brackets, because that part is a new integral which I'm reapplying integration by parts to. So e to the 2x over 2. And then my new integral minus, okay, so this is applying my formula, uv minus v du. Okay, so my new v here, and I'm generating my new integral, and du is going to be dx. So here's my v du. So sorry, my du is dx. Okay, so again, all I've done is taken an old integral, rearranged it into this, and I generated a new integral. And this new integral now I can integrate. Okay, so although I had to apply it twice here, I had to apply integration by parts twice, I did end up with a new integral that can be integrated right there. Okay, So now I can resolve this integral. X squared e to the 2x over 2 minus x e to the 2x over 2. Okay, and I forgot to, no, those cancel out. So, and then I end up with plus, negative is a plus. The integral of that is going to be e to the 2x over 2 divided by 2. So I'm going to get over 4 and then plus c. Okay, just watch out for the signs because that's a negative. It's going to change, flip it over. But there it is. There is the integral of that. Okay, that's the this is my original function. There is the antiderivative of that function.